Hello students, this is Nitya Priya. Even now we are going to see the second concept in our third unit, process scheduling. So these are the contents of our presentation, process scheduling, then the objectives of process scheduling, then different scheduling schemes. Right. First, why do we need scheduling? Why is scheduling needed? Actually, what is scheduling? Scheduling is scheduling the processes who are waiting for the processor is scheduling. Okay. So arranging the processes who are waiting for the CPU. That is scheduling. Right. See, here we see two types of systems. One is uni-programming system. Another one is multi-programming system. You have to understand both. Uni-programming system is there will be a processor which handles a single process at a time and only one program is ready to be executed. So this is uni-programming system. The problem in uni-programming systems is the CPU's time will be wasted because there will be only one program waiting for the system to be handled. So if the CPU completes its process, it will be waiting for another process. Okay, so that is a slow system, and we can say that is an outdated system, right? So here the next case we see multi-programming system. Multi-programming system is on par. Multi-programming system is actually more than one processor waiting for a single processor. In a single computer system, there will be one processor, and for the one processor, more than one processes will be on wait. So this is called multi-programming system. So the CPU can handle only one process at a time. Now the operating system takes a decision on which process to be put on CPU, right? Among for example, n processes waiting, which process can come into the processor, that will be decided by the operating system, and this particular task is called as what? Scheduling. Okay, right. So these are the objectives of process scheduling. The first one is maximum CPU utilization. You know, the process has to be always busy. The processor CPU has to be always busy. So the first objective is to keep the CPU busy. The second one is fair allocation of CPU. Fair allocation means, for example, if process 1 comes at a time, for example 10 o'clock, if the second process comes at 10:15, we cannot allocate the process which comes at 10:15 first. Okay, the process which arrived first should be allocated first. If we allocate the late process first, that will be unfair. Okay, so this is called fair allocation. So fair allocation should be kept. Then the third one is maximum throughput. That is we maximize the number of processes that utilize the CPU. Okay, so we just maximize the number of processes. That's it. Then minimum turnaround time. Minimum turnaround time is the time taken by the process to finish execution. That should be minimized. Then minimum waiting time. Minimum waiting time is to minimize the waiting time of every process. Then minimum response time. Minimum response time is the time when a process produces its first response. Okay, so the responding time should be minimized. So these are the objectives of process scheduling. And now we come to the third concept, which is different scheduling algorithms. Here we see only the brief things about different scheduling algorithms. Later we see every algorithm in detail. Okay, so first is first come first serve. You know what first come first serve is? It is the process which arrived first will be served first. The process which arrived next second will be served second, and so on. The process which has arrived 10th will be served 10th. Okay, so in which order it has come, the same order it will be served. So that is called first come first serve. I hope you understand. So this can also be called FIFO, first in first out. The one which has arrived first will be out first. The one which has arrived second will be out second. The one which has arrived last will be served the last and will be out the last. Okay, so that is called first come first serve. Okay. And the second one is shortest job first. Shortest is, we mean here the length of the job. Okay, so which job takes the minimum burst time. Burst time is execution time. Okay, so process maybe n processes waiting, maybe for example 4 processes waiting. For the process 1, the burst time would be for example 5 minutes, and for the second process it will be 4 minutes, for the third one it will be 3 minutes, and for the first last one, fourth one, it will be 2 minutes. So which is the minimum burst time? The last process. So and the last process, even if it is a last process, it has the minimum burst time, so that will be served the first. Okay, so shortest job first. I hope you understand. The shortest job will be served the first. So that is it. The next one is longest job first, the opposite of it. Okay, so the burst time, the process which has the burst time the greatest will be served the first. The motto of it is to finish up the job or to finish up the process which is lengthy first. Okay, so usually we do this, right? We'll do the work which takes maximum time first. Actually, we'll take up the longest job first in order to make it fast. Okay, so the minimum burst time job will be taken the last because it takes only few minutes. Okay, so that will be taken the last. So this is a motto of longest job first. Then round robin scheduling. This is round robin is we'll keep a time quantum for every process. For example, if 4 processes are waiting, all the 4 processes will be allowed or will be given one time quantum. The time quantum may be 1 minute or 1 second or 2 seconds, maybe anything. But the time quantum is fixed for all the processes. Okay, process 1, if the time quantum is 1 second, process 1 will be given 1 second. After process 1 finishes, the processor will be automatically allocated to process 2, and that will handle the processor for 1 second. So it will be given to process 3, that will handle the processor for 1 second, and so on. Okay, so all the processes in irrespective of their length, irrespective of their waiting time, that particular static time quantum will be allocated for all the processes waiting. Okay, so first process 1 will be finishing, then process 2, then process 3, then process 4, and so on, right? So here there will be 2 cases. One is if the process takes lesser than the time quantum. For example, if the time quantum is 10 seconds and if process 1 is finishing in 5 seconds, what will be done? So what will be done is the process will be automatically handling the processor to the second process. Okay, so without keeping the processor idle for 5 more minutes, it will just hand over the processor to the second process. Right, so this is the first case. And the second case is, what if the time lapses? For example, if process 1 takes more than 10 seconds, what will happen? Nothing will happen. The process will keep the processor only for the time quantum, only for 10 seconds it can keep. If it lapses, for example, if it needs 5 more seconds, so that will be put on hold. So 10 seconds process 1 will execute, automatically it will move on to processor will move on to process 2, then process 3, then process 4. Then what about process 1? It will be kept after process 4. It will be kept on the tail of the queue, waiting queue. So for process 1, process 2, process 3 and process 4, at last the remaining 5 seconds of process 1 will be kept. Okay, so process 1 will take the processor again after process 4 is over. So that is called round robin. Right. So this is priority based scheduling. Priority based is we can always give processes according to their waiting time. Okay, so sometimes some processes will be having higher priority. Okay, the necessity to be executed. So if the priority is higher, whichever job or whichever process has the highest priority, that will be allocated first. Okay, so this is called process based scheduling, and then we'll discuss this later detailing. Then these are the other types of scheduling. Shortest remaining time first. Okay, so this is a preemptive scheduling according to the remaining time. Okay, how long it remains on CPU, right? So it remains inside the CPU for shortest time, so that is allocated first. then longest remaining time first. That is, if the job remains the longest time inside the CPU, that will be allocated the first. So this is longest remaining time first. Then multi-level queue scheduling. Multi-level queue scheduling is queues will be that is the queue is the queue of processes waiting. Okay, so according to priorities, the queue will be arranged. Okay, the jobs or the processes which has high priority will be in a queue, and the jobs which has the second priority or the low priority will be arranged in another level of queue. So like this, multiple levels of queue will be there, will be arranged. So according to the queue, it will be scheduled. Then multi-level feedback queue schedule. So feedback queue is it is according to the CPU burst time. So if a process uses too much time of CPU, it is moved to lower priority queue, and the process if a process is using less time of CPU, that moves to front. Okay, so that is called as multi-level. Then, and these are the useful facts about scheduling algorithms. Some of the useful facts. Okay, so first come first serve can cause longest waiting time, and shortest job first and shortest remaining time first both cause starvation. Starvation is CPU waiting time, that is starvation. Okay, that will maximize CPU starvation. Then if the time quantum of round robin is large, it behaves like FCFS, first come first serve. Then shortest job first is the optimal scheme in terms of waiting time. Okay, and I also added some examples about this process scheduling algorithms. If I explain everything, video will be so lengthy, it will be tough for you to download. So you just work out it on the notebooks, you will understand this. Okay, I hope you understand process scheduling, and that's all about now.